When using Hess's law to draw a reaction diagram profiling the energy, we express energy on the y-axis and the rate of the reaction on the x-axis. The reaction we're going to profile is the reaction of potassium when it is in solid form, reacting with 1/2 of a fluorine molecule in gas form and forming one formula unit of solid potassium fluoride salt. I know it's sometimes a little confusing for students to see this 1/2 situation, and don't be thrown by it. It is often using fractionals to get the proportion we need rather than using multipliers. So that's all that we're saying, is that's a multiplier to get it in the proportion that we need here. Our next step is to look at our reactants and locate them in the available reactions number 1, 2, 3, 4, and 5 that we have. We have potassium solid, and in reaction number 2, I see potassium solid. We need fluorine molecules, and I see that I have fluorine molecules located in reaction number 1. So those are the first two that I'm going to consider. As energies on my y-axis, I just need to pick an energy to start with. We don't have any absolute values. We're looking at the change as we put energy in to drive the reaction endothermically, or energy that's released as the reaction happens spontaneously in an exothermic setting. So we're going to use an arrow pointing up when we plus in energy and an arrow pointing down when we subtract energy out. Let's start with the potassium, and since the potassium is equation number 2, we see that for a potassium solid to turn into potassium gas, we need to plus in 90 kilojoules of energy. That's to take potassium solid and turn it into potassium in a gaseous form. That's known as the heat of vaporization. Next, let's get us some of fluorine to begin with. And to create that, we have a reaction that says a whole fluorine molecule produces 2 fluorine atoms by releasing 151 kilojoules by taking in, it's a positive 151 kilojoules of energy. I don't need to, I just need 1. So really and truly, I need to divide everything here by 2. And that would give me all that I need. And half of 151 is what, 76? So if I plus in 76 more kilojoules of energy, I heat this up, I can turn F2 in gas form into fluorine atoms in gas form. This is known as the heat of vaporization, the energy to change from solid into gas form. This is a salt, potassium fluoride, that we're forming. And to form potassium fluoride salt, we need to have our reactants as ions, not as atoms. So let's look at how we're going to change potassium gas into potassium ions. Do I see that somewhere? I see that potassium atoms, to become ions, need an extra 419 kilojoules of energy. So I'm going to make my line a little bit longer, 419, because that's a significantly bigger number. And that's going to allow me to take my gas form and turn it into a cation. What's that called? The energy to remove an electron? That's your ionization energy for potassium. To get a fluoride ion to react with the potassium ion, we need to take our fluorine gas and turn it into the fluoride ion. And we see in equation 5, the fluoride ion already formed to become the fluorine atom, releasing the electron it has, requires 333 kilojoules of energy to pull an electron off of it. But we want to put an electron on it. So we need to flip this reaction. We need it to say that fluorine gas, when it gains an electron, becomes the fluoride ion in gas form. And instead of being a positive 333, it would be a negative 333 kilojoules of energy. That's electron affinity. As a negative, it's pointing down. Not quite as long an arrow. It's a little less than 419, 333, pointing down. And that's taking fluoride in gas form and turning it into the fluoride ion in gas form. So we've plussed in 90 plus 76 plus 419 kilojoules of energy. And in forming the anion to react with the potassium ion, we have released 333 in that step. We now have our reactants, the potassium ion and the fluoride ion, in fit condition to join together to make potassium fluoride. So for that next step, we'll consider reaction 3. To form potassium, when potassium fluoride salt breaks into potassium and fluoride ions, it requires an input of 800 kilojoules of energy. We're doing the opposite. Again, we need to flip this reaction so that it says when potassium meets fluorine, both in gas form, and forms potassium fluoride salt, it's going to release 803 kilojoules of energy. So, in terms, I've plussed in 900, I've plussed in 90, I've plussed in 76, I've plussed in, added in, heated up another 419 kilojoules of energy. I had a reaction happen spontaneously that released 333, and from this point of taking these two things in the blue box and forming them into potassium fluoride, the salt in solid form that I actually want, because this did say it was in solid form, I have released 803 kilojoules of energy. Again, it's pointing down because the sign is negative, meaning that it's exothermic or energy is being released. Now, to conclude, here's where we started. Here's where we wound up. Let me just draw a dotted line all the way across from where we started to where we wind up. And this difference right here is my heat of the reaction that we've described by all of these steps. How do I find that? Well, let's total things up. 90 kilojoules went in step number 1 right here, plus 76 kilojoules that went in for the heat of vaporization, with the also addition of the ionization energy, 419 kilojoules, the removal of the 333 kilojoules for the electron affinity for the formation of the fluoride ion, and then finally the release of 803 kilojoules for the formation of the salt. And that would be our bond energy. In this case, because it's a salt, we call it a lattice energy. And so I get that that is a difference of 551 kilojoules of energy. So our heat of reaction, the difference from where we started and where we wound up down here, started here, wound up down here, is 551 kilojoules difference. And that is our heat of reaction. Feel free to give me some feedback on anything that I may have misspoke or you found confusing in this process. I'll be happy to revisit this and edit it and get it up to date. Hope you find this helpful in your work.